Today, we're jumping straight into Phaser 3 to see how we can achieve the vertical oscillation effect. Hey everyone, in our last video, we looked at the horizontal oscillation in raw WebGL, how a sine wave will move our pixels left and right to create that smooth, wavy distortion in classic EarthBound battle backgrounds. If you missed it, check it out first, links in the description. I've prepared a starter project to make this easy. It already includes our main background image loaded and displayed taking up our full game size, a placeholder pipeline that just renders out our image as is, and then a tweak pane setup so we can tweak parameters for our shader pipeline. This will allow us to modify things like our background image, and then our size, our amplitude, and our frequency of our sine wave. Here's the pipeline class we'll use. Currently, it's just a pass-through shader. For our vertical oscillation, we'll need to use a few uniforms. We'll have uTime, which is how much time has passed since our game has started. It's going to be used for our animation. A uniform for speed, which helps control the speed of our animation. And then we'll have uniforms for our amplitude and our frequency to control the size of our sine wave. Our amplitude is going to control how far our pixels will move vertically. So our amplitude, this is going to control how far our pixels are going to move vertically. And then our frequency is going to control the number of waves that'll move along our axis. So in our custom pipeline, in order for us to update our uniforms, we're going to use our onPreRender method. Our onPreRender method is going to be responsible for updating all of these uniforms for every frame of our game loop. Phasers are going to handle sending these updated values to our shader, which then will use those values to create our sine wave and then move our pixels around. So now to use our pipeline over in our phaser scene, first we need to make sure we add our pipeline to our renderer. After we add our pipeline to our renderer, we just need to create our image game object, and then we can attach our pipeline by using our setPostPipeline method. And this will allow Phaser to create an instance of our pipeline for our game object. Besides setting up our pipeline in our background game object, the rest of our code in our game scene, this is responsible for creating our tweak pane integration and creating our demo visualization of our sine wave here. And so tweak pane makes it easy to experiment while we're working with our shader. With the integration, we can modify things like our uniform for our amplitude and our frequency in real time to affect our sine wave that'll be applied in our shader. So now that we reviewed our integration, let's build out our shader. Right now our pipeline is set up where we just grab our main texture that's passed to our shader and we're rendering out the original color of the pixel we're currently processing. So now for our shader, we first need to create our sine wave that'll vary along our x-axis for our texture. In this video, we won't be doing a deep dive into the code that we add, but if you are interested in learning more, I'd recommend checking out the first video where we built out this shader in raw WebGL. So to create our sine wave, we'll make a new float. We'll call this wave. We're going to set it equal to our sine function. Now we want to take our out text coordinate, so our coordinate that we're currently processing. We want to grab our x value, and we're going to multiply this by our frequency. And this is going to control the number of waves for our sine wave. Now to get our animation effect, we need to add in our time uniform and then multiply it by our speed. If we don't do this, we won't have an animated effect. Instead, we'll have a static image where our sine wave will be applied to our shader. Next, we need to calculate how far we need to move our pixel for that vertical offset. So for our vertical offset, that'll be based on our amplitude for our sine wave. So let's do a new float value. We're going to call this offset. We'll set equal to our wave, and we're going to multiply it by our amplitude. And now based on that offset, we just need to calculate our new coordinate for the pixel we're processing. So for that position, we're going to do a vector 2. We're going to call this new chords. We're going to set it equal to our vector 2. Now we want to do our original x position. So we're going to do our out text coordinate. We want to grab our x value. And now we want to do our original y value. And we want to add in that offset. And so now this is going to shift our pixel vertically. Now that we have our new position, we just need to sample our original texture and then render out that color. So we can just copy this line of code here. That way we assign it to our GL frag color. We're going to do our main texture, but now instead of our out text coordinate, we want to do our new chords. Oh, and real quick, this shouldn't be out text chord, it should be out text chord for like texture. We'll just fix our reference. So now if we try running our project, if we come back to our browser, we should see our new effect being applied to our background image. So if we update our amplitude to be 0, we should see our original background image. And now if we increase our amplitude, we'll see that affects the height of our sine wave. And now we should be able to modify things like our frequency and our speed to create different types of animations. And that's it. With a few lines of GLSL inside a Phaser 3 pipeline, you can recreate that vertical oscillation effect seen in retro battle backgrounds, or use it for things like water ripples, flags, or any wavy visual you like. If you want to understand the math behind the shader, check out the first vertical oscillation WebGL video in the series. Links in the description. Thanks for watching. If you found this useful, hit like, leave a comment with shader effects you'd like to see next, and subscribe so you don't miss future Phaser tutorials. And if you'd like to support the channel, I've got a Ko-fi page, link in the description. Every coffee helps me keep making these tutorials. See you in the next one.